Last time we looked at the sum, product, sum items, right? We started solving equations. Today we're going to finish. Remember, when in doubt, just write everything in terms of sine and cosine. Cosecant's 1 over sine, right? Cotangent, cosine over sine. Multiply through by your LCD, which is sine of x. We're now at 1 plus cosine of x equals the square root of 3 times sine x. Where to go from here? Well, if this is true, then their squares would also have to be equal, right? If x equals y, then x squared would have to equal y squared. Expand out the left-hand side. Replace sine squared with 1 minus cosine squared. And bring all of your terms to one side. Or cosine squared plus 2 cosine x minus 2 has to be 0. Multiply through by 1/2. So this is where we're at right now. Let's use a change of variable. Let y be cosine of x. What we have now? We have 2y squared plus y minus 1 equals 0. Which can be factored. Y is either a half or -1. We're going to get cosine of x is a half or cosine of x is -1. On the unit circle, which coordinate corresponds to cosine?
P over 3.
Hmm?
P over 3. The x.
The x coordinate, right?
Oh.
So, which x coordinate or which angles have an x coordinate of 1/2? You said one of them pi over 3. What's another one?
Pi over 3.
Here. Get those, pi over 3, 5 pi over 3. And what about for cosine being -1? Just pi, right?
Yeah.
However, how do we get these solutions? By squaring both sides. Just because x squared equals y squared does not mean x equals y. Right? -2 squared and 2 squared are the same, but -2 and 2 are not the same. So what we have to do now is check these solutions. Start with pi. And the easiest thing to do would probably be just to look at this equation here. Because up to this point, we haven't done anything. For pi, I can immediately roll it out because sine of pi is 0. And we can't have 0 in the denominator. So immediately, x equals pi is rolled out as a solution. 5 pi over 3. Cosine of 5 pi over 3 is positive. Sine of 5 pi over 3 is negative. 1 plus a positive is positive. At 5 pi over 3, we'd be saying that a positive equals a negative, which is nonsense. That means 5 pi over 3 is not a solution. Pi over 3. Both cosine and sine are positive, so at least we'll get positive equals a positive. Now just actually check to make sure it works. Where is that cosine of pi over 3 is a half? What's 1 plus a half? 3/2. What is sine of pi over 3? Root 3 over 2. Multiply that by root 3, what do you get? So it's root 3 times root 3 over 2.
Root 3 times root 3 over 2. 2.
Anybody multiply fractions? Straight across,
It
right?
would be 2 root 3 over 2. 6 root 6.
So it's root 3 times root 3 over 2. What's root 3 times root 3? What is it?
Root 9.
Which is what? What's the square root of 9?
3. 3 over 2. It would be 3 over 2.
Which is exactly what we said the other side was. 3/2 equals 3/2. Pi over 3 is the solution. That's the only solution. I'm going to stick with how I did it in my notes, but you could also just have cosine of x equals 1 plus root 3 sine x, and then square both sides. Expand, replace sine squared with 1 minus cosine squared. All right, now move everything to one side. What are we going to get? 4 cosine squared minus 2 cosine minus 2 equals 0, and divide or multiply everything by a half. Which looks very similar to the one that we did last time. In fact, the only thing that's going to change from last time, your signs are going to change. There would be 2y plus 1 and then y minus 1. Cosine of x is negative a half, or cosine of x is 1. Start with cosine x equaling 1, that's the easiest one. That's at 0. Right. Now, where's cosine of x negative 1/2? What angles correspond to an x coordinate of negative 1/2?
2 pi over 2.
And
Or the x coordinate?
that's what the cosine is, right? Cosine is x, sine is y, on the unit circle. But again, we squared both sides, which means we have to check these solutions. 0 is the easiest one. Cosine of 0 is 1, what's sine of 0? 0. 1 equals 1, 0 is a solution. Pi over 3. Cosine of pi over 3 is a half. Sine of pi over 3, I'm sorry, why am I doing pi over 3? 2 pi over 3. Cosine of 2 pi over 3 is negative. Sine of 2 pi over 3 is positive. You get negative minus positive, which is negative. You're saying a negative number equals 1, which is nonsense. That means 2 pi over 3 can't be a solution. So we can rule it out. Now check 4 pi over 3. Both sine and cosine are negative. You end up with a negative minus a negative.
And that can't equal 1.
Could. Depending on the values, a negative minus a negative could be either positive or negative. So this could be a solution. Now we actually have to try the values. Well, we know what cosine of 4 pi over 3 is. Negative 1/2. What is sine of 4 pi over 3?
Sine would be the negative root 3 over 2.
What was root 3 times root 3 over 2?
Just 3 over 2.
So you have 1, or negative a half, minus negative 3 halves. That's negative a half plus 3 halves, which is what?
2.
Not 2.
3 halves plus 1/2.
It's 3 halves minus a half.
Oh, just 1/2. Oh, so 1.
It's 1. 4 pi over 3 is a solution. There's your two solutions. 0 and 4 pi over 3. Everything's already passed out.
It's over there.
Yeah, okay. I also dropped off the unit circle as well.
All right. Thank you.
So that's all in there for you. Square both sides. Expand out. Replace cosine squared with 1 minus sine squared. Move everything to one side, rearrange. We have 5 sine squared minus 2 sine. Looks like minus 3 is equal to 0. Let y be sine of x. 5y squared minus 2y minus 3 is equal to 0. And can that be factored? Yes. 5 minus 3 is 2. So that has to be 5 times 1 and 1 times 3. Higher one's going to take the minus. So it should be 5y plus 3 times y minus 1. Y is negative 3/5 or y is equal to 1. Sine x being 1, that's the easy one to solve. And you can bring up the unit circle for that. That's pi over 2. Now, sine x equals -3/5. Do you see a point on the unit circle that has a y-coordinate of -3/5? Bummer. It means it's not an angle that's on the unit circle.
Was it take a reference maybe?
Well, even if you try to do that, you still, that angle is not listed. So it's going to have to be an inverse sine involved. But if we do look at the unit circle, where is sine negative?
In the third quadrant?
And where else?
In the fourth quadrant?
What is the range of the inverse sine?
From 7/6 to 11/6? Negative pi over 2. Pi over 2.
Negative pi over 2 to pi over 2. We're looking for angles between 0 and 2 pi. That would mean our quadrant 4 angle is the inverse sine plus 2 pi. Like, so you just take the inverse sine, it's going to give you something between negative pi over 2 and 0. We want between 0 and 2 pi, so just add 2 pi to get it's complementary. It's not complementary. Coterminal angle. That's the quadrant 4. We still need the quadrant 3 angle. There's our theta. That's the inverse sine. But remember, that's going to be less than 0. That's negative. This let's just call it theta prime. I'm sorry. There's theta prime. That is the angle we're looking for. We know a couple of things.
The middle angle 90 degrees.
That's going to be 90. Which means I'm going to do it this way. That angle is the absolute value of theta. then isn't our angle in question pi plus that absolute value? Pi minus theta. Because remember, theta is negative. So the absolute value of theta would be negative theta. That was one way of looking at it. You could also look at it knowing this entire angle. Because we know what that is. That's the inverse sine plus 2 pi. Then it's just that inverse sine plus 2 pi minus an extra pi. What do you think now? Minus pi over 2. So you could also have 3 pi over 2 plus that inverse sine. They're both the same. Now comes the fun part. Because we squared both sides, which means we have to actually check these solutions. Pi over 2 is easy. What is cosine of pi over 2?
One pi over 2.
Cosine of pi over 2. Zero. And we already said what sine of pi over 2 is, right? It's 1. You get 0 equals 1 minus 1. Is that true? What's 1 minus 1?
0.
Yeah. That's a solution. If we look at this angle. This is our quadrant 3 angle. Both sine and cosine are negative, right? Which means this will be negative. 1 minus a negative is positive. Negative can't equal positive. That means that that angle is not a solution. Quadrant 4, sine is negative, cosine is positive. You'll get positive equals positive. All right, well, that's good. Now you just have to actually check to see if that is true. I'll leave that to you. That is true. Just plug into the calculator. Oh, actually, shouldn't need to do that. Because we've worked with this before. That would be a 3, 4, 5 right triangle. Cosine would be 4/5 at that angle. That is what, 8/5? One. Uh-oh. oh, never mind. I'm being an idiot. Alright, so that's 8/5. The sine of that angle would be -3/5, right? So we get 1 minus -3/5 is 8/5. 8/5 equals 8/5. That's the solution. And there's our two solutions. Those were not as straightforward as the ones we did last time, were they? But notice that they all, the ones that we did on Wednesday plus now the ones up here, they all had one thing in common. They was all just x. And they were all trig functions of just one single angle x. What if it's not? Sine of 3x equals -√2/2. Now, believe it or not, a problem like this isn't actually that difficult. First thing to note, we know that we want our x to be between 0 and 2 pi. Oops, not x, sorry. That means 3x has to be between 0 and 6 pi. Right, just multiply everything through by 3. That's important. Now, what I'm going to do, I think, instead of that, let theta be 3x. Where does sine equal -√2/2?
5 pi over 4.
And where else?
7 pi over 4.
Are they all the angles between 0 and 6 pi?
That's 6 pi.
They're not, right?
Yeah.
Here's what I'm going to do. Let's do this. Solution set for theta. We have those two. add 2 pi to each of them. That is now between 0 and 4 pi. Add 2 pi again. We're now between 0 and 6 pi.
And those are the 6 ones,
Right? So these two here were between 0 and 2 pi. We added 2 pi. That now gives us between 2 pi and 4 pi. Added 2 pi again. We're now between 4 pi and 6 pi. So these are now all the solutions. Remember, 3x had to be between 0 and 6 pi. But we said theta is what? 3x. Just multiply each of these by 1/3. That's your solution set for x. So I'm not going to call that's for x because it is the solution set we're looking for. Right? Again, just divide each of those values by 3, which means you're just going to have denominators of 12. There is our solution to this equation. Like I said, not that difficult, is it? Definitely not easier than the ones we just did. Cosine of x over 2 equals a half. Well, again, we now have a half angle. There's actually 2 ways we can do this. The easy way and the harder way using the identity. I'm going to use the easy way. We want our x over 2 to be between 0 and pi. Again, just do a change of variable, we don't have to. Cosine of theta equals 1/2. And then what I'll do is I'll just treat it like we've been doing theta between 0 and 2 pi for now. I'll restrict it later. Look on the unit circle. Where is cosine 1/2?
5 pi over 2.
Where?
5 pi over 2.
And where else?
And 5 over 2.
And that's for theta between 0 and 2 pi. But we only want 0 to pi. which, if any, of those angles are between 0 and pi? Only one, pi over 3. Now just multiply that by 2. We only have one solution, 2 pi over 3. So again, those are pretty straightforward if you're dealing with just a single trig function. But now what about something like this? Well, double angle identity on sine. Two sine x cosine x, right? Factor out cosine. We get cosine x equals 0, or, no, I am just going to do this. You should easily be able to see, or sine x is negative a half. Where does cosine of x equal 0? And where else?
3 pi over 2.
Now let's look at where sine of x is negative a half.
Or 6.
What was it?
11 pi or 6.
Where else?
7 pi or 6.
Since all we did was use an established identity, all of those are solutions. And we didn't really do anything fancy other than use an identity. And identities are true for all values of x. Those are the 4 solutions. use the half angle identity on cosine. It's what? Plus or minus square root of 1 plus cosine x all over 2, right? And that's being squared. When you square a positive or negative, the result's the same, right? That's nice. We're going to get what? 1 plus cosine of x on the left-hand side?
Mhm.
With everything to one side?
So do cosine x for 1.
So we'll change the variable, but I'm going to give PowerPoint a minute to catch up. It's starting to fall behind. No, that's going to be a problem. You're going to have to use quadratic formula here. I'll let you go through that because this is a known solution. We actually studied this solution quite a bit in math. One plus or minus root 5 all over 2. Oh, but wait a minute. One plus root 5 over 2. Isn't that larger than 1? So that first one, I'm not going to draw that. I'll do it this way. That first relation is the empty set. Has no solution.
that's not good.
Huh?
It's less than 1?
1 minus root 5 over 2 is between -1 and +1. Which means that does have a solution. What is the range for the inverse cosine? Which means for one of our solutions, we don't have to do anything fancy. Right, just the inverse cosine of 1 minus root 5 over 2. 1 minus root 5 over 2, is that positive or negative?
Negative.
Which means our cosine is going to be where our angle would be in quadrants 2 or 3. The inverse cosine gives us quadrant 3, right? Or quadrant 2, rather, it gives us. Let's say that is our angle x. That is the inverse cosine, right? We want that angle. Because that angle is also a solution. Oh, I guess it could be. I think it is, yeah. And so that has to be a 90-degree angle between the lines. So I could do that, right? It would be x plus pi over 2. Right?
Is the blue angle the same angle as x?
No, that's a 90-degree angle.
Yeah.
I think one that I did, the way that I did it in my note, but it should be the same, is went, do one full revolution. No. No, it wouldn't work. What, 2 pi minus that anyway? Yeah, that's what I did. That works. One full revolution is 2 pi. And I said, oh, but if I add this rotation, right, so in other words, I'm taking that away, I'll get my desired angle. But this is precisely negative x.
Yeah.
So 2 pi minus this angle. That's how I did it in my notes, but they should be the same. I'm actually going to just double check that real quick. No, they're not. Oh dear. Okay, that's why. So, addendum. That does not have to be 90 degrees.
So that angle is not negative x.
So here's what I did.
The angle is negative x.
That is negative x.
Yeah. Those. Because 2 pi is a full revolution, 360, right? So.
That should be the solution.
And negative cosine, or negative inverse cosine 1 minus the root 5 over 2, that's x.
Yes. Inverse cosine. Oh, that's not true either. Oh my god. Okay, so that's going on. Those should be the same. This is the reference angle. X and X prime should have the same reference angle. Reference. Because I'm trying to find one, should go right back to 2 prime minus the inverse cosine. Still checked off. This game is so annoying. Oh. Yeah, of course I'm not going to do the same. Okay. I was just.
So x equals 2, x equals 2n x plus inverse cosine 1 minus square root 5 over 2, where
That's true. Okay, I was just being an idiot. I was looking at the wrong thing. Of course, they're not the same angle. The cosine of them should be the same, and that's what I wasn't checking. Okay, yeah, that's right. I actually like this way better, now that I actually did it out. That is our reference angle for the second angle, right? Which is this here. These two angles have to have the same reference angle. What's this reference angle? Pi minus x, which is this here, right? But then this angle would be pi
minus the
plus this blue, which was this angle. So it's pi plus this, which is the 2 pi minus the inverse cosine. Actually, I like using reference angles better. And we did nothing fancy other than just use an identity. So those are both solutions. Divided over 2 and then 2 pi. So I was just checking the wrong thing, or to check the right thing. I would know that they were correct. Okay, now from here, I'm basically flying blind. Because I actually didn't get a chance to do these last semester, which is what my notes are based off of. So let's go about this and have some fun, see what we get. Double angle identity on cosine, there are 3 of them, right? 3 forms, cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. Oh, well, we have a cosine of x in there, right? That means the form that we're going to want is the 2 cosine squared minus 1. Oh, this one's, okay, I love this one. That's going to leave us with this, right? 2 cosine squared plus cosine is equal to 0. Factor out cosine. Use the 0 property. Cosine is 0, or cosine is negative 1/2. We already saw where cosine was 0. Actually, hold on. Did we do this one already? No, sine is negative 1/2. We know that cosine of x is 0, right? That one we did do. That's pi over 2, or 3 pi over 2. Where is cosine negative 1/2?
So 1 pi over 6, and 1 pi over 6. All cosine.
Cosine, yeah.
4 pi over 3.
And
2 pi over 3.
2 pi over 3 and 4 pi over 3. And again, we did nothing fancy here, right? We just used an identity. So all 4 of those are solutions. this one. That's not helpful. This will be. No. Oh, yeah, that is helpful. Okay. All right, right tangent of 2x, sine of cosine. Multiply through by cosine of 2x, get rid of the fraction. That'll bring me to sine of 2x plus 2 sine of x cosine of 2x equals 0. Double angle identity on sine is 2 sine cosine. Now you have a 2 sine of x common. Factor it out. So sine x equals 0, or cosine x plus cosine of 2x equals 0. Now we need to use a double angle identity on cosine. Cosine of x. Use the 2 cosine squared minus 1. And that second one is of course quadratic. Can that be factored? Yes. In fact, did we solve one like that already? good, right? 2 cosine squared plus cosine minus 1 equals 0 right there. We got 3 solutions out of that. Pi over 3, 5 pi over 3, and pi. So I'm not going to redo all that work. What was that? Question number 9. All right, so that solution's from question 9 at the very start. Where is sine of x equals 0? Again, this is an easy one. 0 for pi. Pi is repeated, by the way, so you don't need to write it twice. And we again did, we only did one thing that was fancy. We multiply, where am I? We multiplied through by a cosine of 2x, right? Which means cosine of 2x can't be 0. None of those, when you multiply by 2, will give you a cosine 0. Right, you need pi over 4, 3 pi over 4. You need an odd multiple of pi over 4 to get an odd multiple of pi over 2. When you double it, none of those are odd multiples of pi over 4, so we're good. They're all solutions. Zero, pi over 3, pi, 5 pi over 3.
Is this one the word slide?
Mm-hmm. And so I'll continue from number 17. Let's do this. And again, these slides will be posted after class. So I'll make you do this on your own for a bonus chance on the third exam. And same with that one. So 18 and 19. Do it at home.
Or you just post it, right?
I'll post it, yeah. It'll be posted on the SharePoint. I post it right after class. So these on loose leaf paper on your own. Each one will be worth 2.5 points on the third exam, which should bring the total extra credit on exam 3 to 10 points. Right, because there are 5 points previous prior to this.
Not if you got it right, though.
Yeah, well, I'm saying, opportunity. Brings your opportunity up to plus 10 points. Which is 10% of the exam 3 grade.
Do we get a green sheet for the final exam?
I handed it out already on, wait till I'm done because I still have them with me. Right? So you bring these in with you on exam day and just turn them in with the exam.
And what day is that exactly?
I'll get there.
Okay.
Okay, so that's that. You do have 2 homework assignments. Right, you have your product to sums on the product homework, that's number 23, and then solving equations, that's number 24. They're both due on the 7th before the exam starts. The exam is scheduled for Wednesday, 10:15 to 12:15 in this room. Again, the exam is broken into 2 parts. Part 1 is the non-comprehensive. That's worth 70 points. Part 2,
Non-calculated?
and that non-comprehensive,
What is that?
new stuff. Just stuff we've done since exam 2. And then part 2 is worth 30 points, and that's the stuff from exams 1 and 2. So the heaviest focus is on the new stuff. I have to make it comprehensive, that's college policy. Otherwise, it would have just been 70 points and then I would have made the part 2 and 3 extra credit for exam 1 and 2, but can't do that, so here I am. And again, exam 3, 10:15 on Wednesday in this room, or go till 12:15. If you do not arrive on time, you're not getting extra time. Because I have another exam right after this one. So that's it at 12:15, we pack up, no matter what time you get in. It's the same rules, all the same rules still apply. If you have not gotten the reference sheet yet, I did get it now, right? Yeah. It just felt like I got a lot here, but I just want to make sure. If you're not getting the reference sheet, make sure you pick it up. I will see you on Wednesday. Let me just stop all the recordings.
Yeah, this QR code doesn't work.